Thank you so much. We should be clapping. Um, I really think that zeroed in on all of the central issues, and I'm very grateful because I'm going to be facing Jim Berger shortly. And I'm just going to propose that I think one of the big things that you mentioned is that this great big difference between the Bayes factor and the p-value is they're using a point null hypothesis and giving a lump of prior to this point null, which really weighs it so heavily, it really biases things in favor of the null. So it's no surprise that they're finding evidence either weakly against the null or even evidence for the null. And we know Jeffrey Lindley paradox, and in a sense, that's what they're playing on. Would you say that is kind of the main issue? Because, oh, I wanted to mention, I found a quote of Jim Berger's the other day where he says, p-values are reasonable measures of evidence when there's no a priori concentration of belief about H naught. And this idea of the prior concentration was supposed to be reserved for cases of laws that have been otherwise well corroborated, not in these cases where we're just checking maybe if we have a genuine effect or whether a parameter should be entered into a model or something. Would you say
well,
that?
I mean, I think it's useful to have a way of thinking about statistical evidence that, well, multiple ways of thinking about statistical evidence, and some of them that aren't affected by where we believe the parameter to be concentrated, because otherwise we wouldn't have an account of model testing or the like. But I do think that the spike is a major part of why they seem to get differences. And the fact that they only consider fixed end designs, right? None of these arguments seem to consider sequential testing, which would change things quite a bit, or cherry picking. But with the two-sidedness is a big thing, because you're essentially affecting your Bayes factor by a factor of 2, just because you've included an alternative that has almost no posterior probability in the calculation.
That's a very interesting point that you raised, that they're averaging in likelihoods of points, knowing that really it's not in that direction at all. And so they know they're going to, yeah, I hadn't thought of that. Okay, let others jump in.
Glenn Sanger has a hand raised.
Yeah, or we write questions. That worked well last time.
In the comments, yeah.
In the chat.
Yeah.
I see that there are quite a few in the chat, so let me see.
I was not seeing them, of course, during the presentation. So if you
right.
want to pick one and ask, then that might be the best thing, because I can't go back and read all of them.
No, that's okay. I can pick some of them out. Richard Gill.
Yeah. Well, okay. I was making some chat remarks, responding directly to things you said. In particular, you had this nice table of names of different odds ratios, and the Netherlands Forensic Institute, they have one like that, which all their scientists use giving evidence in court, and they give courses to judges and lawyers in what they mean. And okay, but they have the same disadvantages as the ones you mentioned, but moreover, in criminal cases, and this is intended for use in criminal cases, the burden of proof is pretty strong. So at least they go for pretty big likelihood ratios before they start saying the evidence is whatever. Okay, so they don't, and the words are attuned to modern Dutch popular usage. So for a while they will be okay. And then I just also had a few remarks about what about spike and slap ideas. I've recently been playing with JASP and actually doing the things it does in R. And I found that that idea is very, very sensible. And indeed, you have a possibility that something could be positive or negative, and they're both possible usually. And there's also a serious probability that it could be more or less zero, or not importantly large. And in I think, well, we had a little discussion with is it Yasaku Okubo, who complained about uniform priors. But these people don't use uniform priors. They put what they call a vague prior, which just means a pretty wide but easy to use in simulation and in also in numerical computation if you want to compute directly. And put a nice normal distribution on the log odds of the null hypothesis and a big lump of probability on the null hypothesis. And my experience looking at some corona data on hydroxychloroquine was that that Bayesian analysis seemed to me to make much more sense and much sensibly express to ordinary people what the information was in that data than the classical p-value analysis. These were samples with tiny sample sizes of 40 or something like that, and they led to the French doctor, what's his name, touting the stuff and Trump starting to drink it, and then some of his supporters finding it in the aquarium, cleaning fluid and killing themselves. Though possibly that was a murder attempt, we don't really know. But anyway, if you actually do the p-values for those things, they are p-values which are just under 5%, but the Bayes factors are clearly not. They're sort of okay. They suggest there may be something there worth further investigating.
Yeah.
Yeah. So.
I want to jump in.
Okay. Yeah, that's what I mentioned in the chat.
Yeah.
Do you want to jump in, Stephen?
Sorry. Oh, I have a list of people with questions. Did you want to respond or comment on that?
So if you're using JASP, then many of the Bayes factors in JASP are computed using my software, and so
okay, great. So it must be good.
Right. It does work pretty well, I have to say.
Yeah,
but
I found the accompanying text very confusing, because actually they do test then estimate in sense, or test and then test again, and I think this is really against a true Bayesian philosophy. So I would
I'm not responsible for the text, so
no, exactly. I would change that text. I know that the team who puts that all together has many fights about these issues.
Yeah. So
can I make a comment about the Rowell trial?
Yeah.
Yes.
Yeah. So, I mean, Richard Gill, that is, referred to a p-value from the Rowell trial, but this was not a legitimate p-value anyway. The trial is not a randomized controlled trial.
Yeah, so this is
the variation in the data, the true random variation is vastly underestimated by that trial. It's much bigger than the trial suggests.
It's not
yes, I agree there.
About p-values, right? So one of the issues with Bayes factors, and I think one of the things that drives their adoption at this point is because the evidence is penalized in various ways that you wouldn't necessarily think are necessary. That is the use of two-sided tests when you don't have to, and the use of point nulls or overly broad point nulls with overly broad alternatives. What that means is, so you've got this evidential, you've got a penalty on the evidence, and in the context where you're worried about the quality of the p-values, this kind of makes sense because but it's arbitrary. What I mean is that there's no reason why this is a property of the Bayes factor. It's just a property of the particular choices that were made by the people who set up these particular Bayes factors. And in our context where we're skeptical, they seem to work. But if you take them to another context where we don't have reason to be skeptical of whether the p-values are illicit p-values or not, they may not work as well because they're penalizing the evidence perhaps inappropriately. So if you've got inappropriate p-values all over the place, then of course having some sort of way of penalizing the evidence that is kind of Procrustean will do well in that situation, but not necessarily generally.
Okay, so I have a long list. How about Christian Henning wanted to raise something?
Yes.
Yeah.
So I have two questions. One is a technical one that refers to what I think Bayesians call spike and slap priors, right? So if in your example, I think actually the prior probability is 80% that they can't predict anything and it will be 0.5, right? And I somehow distribute the remaining probability mass about the remaining parameters in a continuous way. I'm not even sure how the Bayesians would compute Bayes factors there, right? Because if you compare 0.5 with any single other parameters, it's got to be infinity, right? So this is not how it's done. Probably they take the probability of the whole rest, but then it totally depends on how you distribute the probability mass over the remaining parameters. Okay, that's one thing. The other thing is that you are kind of advertising the statistician to be a frequentist and the Bayesian at the same time. One thing that worries me about this is that I always get confused when, to me, it's not clear. Somebody does an analysis and they talk about probabilities and they don't say what the probabilities mean, right? So if you are a frequentist, then a probability refers to a data generating process that does something in reality. In Bayesian statistics, it's not so clear, right? Because if you're a proper Definitian subjective Bayesian, then it's clear, right? Everything is belief. There is no such thing as a true parameter. There's no such thing as a data generating process that is modeled by this. However, more modern Bayesians give me the impression that they basically often mix up things. So they kind of understand the sampling model as a frequentist one, but then the prior is not a frequentist one. And I wonder whether it even makes sense. And I mean, of course, Gell-Mann tries to advertise also to interpret the prior in a frequentist way, which makes a little bit more sense. But I think, I mean, we should not so much be everything at the same time that in the same analysis we mix up things. I think in every single analysis, it should be very clear what we mean when we talk about probabilities. And many Bayesians in particular, I think, are not clear about that and mix up two concepts in the same analysis.
Yeah, so I agree, and that's so I didn't talk about the I didn't talk about arguments or argument 2 of the redefined statistical significance paper, and I think that's a case where there's a big mix-up in what probability means, because you have prior probabilities that are used as a Bayesian would, along with some sort of like there's an assumption that they're kind of sampled from an urn, but they're called prior probabilities, and it's not really clear what kind of probabilities they are. And then power is used and type 1 error rate is used. And so there's a kind of big confusion about what these probabilities actually mean. And I definitely agree with you with the need to keep things clear. So I don't want to make any strong claims about how to mix the two, because I think I'm not entirely sure.
And I think it's because they did that in that paper that people are more confused than ever about type 1, type 2, about Bayes factors and power and so on. I think connected with this, Samantha had a question on objective priors. You want to ask that?
Thank you, Deborah. Richard, the idea of objectivity. So we're getting back to Richard's comment about how people are being taught to use the rule of thumb to evaluate the Bayes factors in an automatic fashion. So this idea of objectivity kind of leads people to want to define processes that can be conducted without thinking, which is one of the things that you are bringing up several times in your talk. And then you ended up showing that you can't come up with a general procedure, which is one, I guess, means that they're not thinking. So is that's because I didn't write a question there, but I suppose the question behind my comment is that you're saying that you can't come up with a generic procedure which would avoid thinking. Is that what you're trying to show?
So I think in general, yes, that's true. Jeffries actually had an account which he thought of as being objective for estimation, right? So I really like the idea of objective priors because I think they're quite elegant in the question of what it means to not inject any prior information into an analysis is a super interesting one from a technical perspective. And so the ability to kind of construct a set of priors that would be in some sense objective, I think that that's quite an interesting thing to try to do. But interestingly, Jeffries had different priors for testing and for estimation because you have to, if you try to use the same priors to compute a Bayes factor as you would in estimation, then in general things blow up because you end up with non-informative priors, and your prior probability will be distributed across, say, an infinite number of possible outcomes, and so your Bayes factor will be in favor of the null to any arbitrary degree, and it always will. And so this is a objectivity in what it means in testing is really difficult, and in estimation it's a little bit easier. So I'm not sure how to solve that problem for testing, and I don't know that there is any way of doing that for a Bayesian.
Yeah, thanks.
So I have Frank Zanker on my list with questions.
Yes, hello everybody. Thank you very much. Thank you for the talk. Thanks for arranging. Two brief questions on two slides, if I may. This is slide 30 on Jeffries' scale, and then on one solution in 44 on slide 44. And so as for Jeffries, I've been trying to find out how he came up with his categories, and I've been completely at a loss. So I wonder whether you have, did he look at the moon and come up with the numbers, or what's the genesis of, because I can't find any epistemological reasons.
So that's in theory of probability, which I don't, is locked in my office. Been locked in my office for a few months now. But this was I
have a copy in front of me, Richard.
Yeah. Well, if you have it, you can, what I remember is that it was his sense that he was looking at log Bayes factors and thinking about how big these struck him. I know that there's not any, I mean, you could try to come up with some sort of objective calibration of this kind of evidence scale, but how would you do that? It's always going to, in some sense, go back to the changes in belief, and beliefs are inherently subjective. So, I mean, there's a sense, and that's all you have.
Okay, but then it remains subjective. Fine, yeah, I can live with it.
Yeah.
The other question is a remark that you made on 44. It's one of the solutions that are offered by people in the redefined statistical significance trend. And there is, I think it's from Johnson, where it says you take a best estimate that depends on power. And then your sort of side remark was, but that's very odd now that the hypothesis that we're testing depends on n. And I couldn't follow why that would be odd.
Ah, okay. So let's say that I am interested in whether some true parameter, let's say our probability in the ESP case, we were interested in what the true probability is of that future teller. And then I tell two people to go off and design experiments and then to analyze the data and come back to me. Now, if it were the case that my prior beliefs depend on the design of the experiment that they choose, that would be really weird, because it's like I'm assuming that somehow their experimental design affects reality, or my belief in that, even that person, that that person's ability to tell the future, right? What does their experimental design have to do with my belief in their ability? It has nothing to do with it, right? So when you choose your alternatives based on power, that implicitly makes it depend on n, which means you would have to know what the experimental design was before you could come up with a prior, which is backwards. Does that make sense?
Yeah, that makes sense for the case you're describing. In other cases, I would find it quite reasonable that you demand a certain amount of data before you even take the data seriously and calculate anything like the base factor. For the case you're describing,
in general, so true. Where you might have something like for a small sample size where you can't check certain kinds of assumptions, you might want to choose a particular test. But for larger sample sizes where you can check certain assumptions, you might have a different test that you would do. That's possible, but we're talking here about the actual hypotheses that you're testing. Which is a bit strange for that to depend on the.
Well, I think Jim Berger imagines if you assign high power against an alternative, then you must have high belief in it. That's the way he looks at it. But anyway, that's a common move. Okay, on my list I have Mark Kaiser. Is Mark here? If he's not, then Yusaku.
Yes, thank you so much for this interesting talk. Yes, in general, I agree with you that base factor could not offer a complete solution to this statistical walls. But this is my opinion, but how about the idea that base factor could offer a frequentistic perspective of model selection or hypothesis testing? Even though base factor have been used to Bayesian analysis, some researchers have pointed out some frequentist properties of base factor. How about this idea?
So you could do that. Now, I think, well, at least for the base factors that I have been involved in developing, what you'll end up with a particular very reasonable class of priors is that the base factors are really only dependent on the frequentist test statistics. And so, for instance, in our Bayesian t-test, what you find is that the only input to the calculation is the t statistic and n. And so if that's true, then the frequentist properties of the Bayes factor will be the same as the t-statistic. And so you're essentially doing a t-test anyway. And if you found that that wasn't true, and I haven't really found any cases where that's not generally true, then you would have to know why. Why would your Bayesian evidence be so different from your frequentist evidence? And then you'd have to kind of think about that on a case-to-case basis. But for the most part, if you were to treat the Bayesian evidence, the Bayes factor, as a frequentist test statistic, you end up with just the typical frequentist test that you would typically apply, which is fine, right? That's kind of what you would want to happen, I think. It would be very strange if that didn't happen.
Yes, thank you very much.
Questions, maybe these two go together. Karthik and then Gary McClellan.
I just had a comment. I don't have a question, so it's all good. Thank you, Deborah.
Right. Did he say he was? Yeah.
I meant you can pass me over. I just had a comment in the chat window, and I think I'm good for now. Well, if it is my spotlight, I might as well ask a question. Richard, I had a question about slide 20.
Yeah, let me go back.
There, it seems to me that the likelihood functions are being computed using sampling distributions. Is that kosher in a Bayes factor analysis as opposed to using an underlying likelihood function? I've seen this in other places where people use sampling distributions. Is that normal?
I mean, so this is the yes, this is kosher. So I mean, it's the probability of the data under the various alternatives. Can you flesh out why you wouldn't think this was kosher? I mean, does this get back to Christian's point?
So there's another way in which you could think of the likelihood function, which is just there's a theta of 0.5 or something, and then you multiply 0.5 61 times and another 39 times to get a whole likelihood for the whole data. Will that give you a different?
I see what you mean. Yes, it's equivalent.
It's equivalent. Okay, that's the question I had. Okay, thanks.
Yeah.
Gary McClellan.
Hi. Can you hear me?
Yes.
Yes.
Okay. Thanks for the great presentation and the very nice slides. Certainly fomented a lot of discussion. My question is, if we're not going to drop P to 0.005 and we have these concerns about Bayes factors, what shall we tell someone tomorrow to do when they analyze their data?
So I don't have any general recommendations, because I think that depends on what you're trying to do with your data, right? I mean, there's data is used in all kinds of ways, and I think that in my line of work, that is cognitive psychology and interpreting randomized experiments in memory or perception, I think the use of confidence intervals, confidence curves, p-value curves, I think, and goodness of fit tests and the like, I think that is sufficient for what I do. I think that, and Bayes factors, I mean, there's no reason why I couldn't use a Bayes factor as long as I understood what I'm actually computing. Now, as for other people's areas of research, I don't want to speak for them. So yeah, I'm not sure what I would tell people, say in your field, to do tomorrow. I think there's a lot of discussion of that, but the idea that there's a general way of calibrating p-values to Bayes factors, that's what I'm opposed to. And even I'm not opposed to dropping p to 0.00 or dropping alpha to 0.005. I like that is something that may actually be valuable in some areas of research. I just object to the argument for it, if that makes sense.
Yes, thank you very much.
Okay, good. I see Mark is here now. Do you want to ask the question?
Thank you. I got kicked off my internet for just a moment. Can you comment on cases where, we don't assign the models equal prior odds, and so posterior odds are not equal to the Bayes factor, and in fact, you may not be able to compute the posterior odds from one overall prior, like group comparison. So I think that might have something to do with Jim Berger's thoughts about multiple testing and being able to handle things through prior odds. Do you have any comments on that?
Yeah, so I generally consider myself someone concerned with quantifying or assessing statistical evidence, even as a Bayesian, and I'm not generally too concerned with the idea of either prior odds or posterior odds, right? So the prior odds and the posterior odds are kind of devices to help me think about statistical evidence in some way, right? So they don't actually have to exist for me to use the Bayes factor. Now, you could posit them, and they don't have to be one-to-one. And I think one of the mistakes that will often make is to have a set of models and to just assume that you can equally divide the prior probability amongst them, and there's no real reason for doing that. And so what Jim Berger would suggest in the multiple testing scenario is that the fact that you have multiple hypotheses means that any one of them should get low prior odds. But as far as I can tell, there's no real justification for that. Right. Why the number of hypotheses that you're testing would affect your belief about them, I don't understand as a Bayesian. That doesn't make sense to me. But that is the kind of Bayesian solution to multiple testing. I think what's really going on here is that Jim Berger, who, I mean, he's claimed to be a frequentist, has frequentist intuitions, like all of us who are statisticians. We all have frequentist intuitions, and we can try to wedge those frequentist intuitions into a Bayesian framework to get the result that we want. And there's something that is useful about that, useful to try to push your theoretical approach and see what happens. But I don't see any justification for it. I think what he's doing is he's using his frequentist intuitions and trying to get the result that he wants. That's my thinking.
Very good.
See what he would say to that.
And that is what I shall say when I meet him at the debate in a few weeks. And let me just ask if there was any other question that somebody was keen to jump in for a moment. Okay, I thank everybody for coming. I'm going to dawdle on here for a moment with
there was another question. Sorry.
Sorry?
There was another question. Celine wanted to know if BFs are sensitive to sample size or power.
We took that up.
Oh, you did? Okay. Yeah. Sorry.
You know,
I have a question. Okay. No, actually, I don't have a question. I have no questions. I'm so old I only have answers. But look, I've been a consulting statistician for 50 years now, and I think statisticians and the scientists need to work together and the statistician has to understand the scientist's problems, and that comes from long time working together. And the scientist has to be patient and learn a bit of statistics. And you cannot expect every statistician to be able to do that. You can't expect every psychologist to be able to become a top statistician. You don't. Science is done by many different people of many different disciplines, and we need to work together. So that's my solution to all the problems, is to assign 2 statisticians to every statistical problem, an old one for a bit of sort of wisdom and experience, and a young one who actually has heard about some of the new things that are going on and has time to do a lot of hard work, and let them work together with the dentist, psychologist, economist, or whatever. That's how it works. That leads to fantastic results, as I have experienced.
So everybody gets a statistician and a data scientist.
Well, a real data scientist a data scientist has got 3 capacities. They know about statistical theory, they know about analyzing data with modern computers, and they know a great deal about the field they're working in. Otherwise, they're useless. And okay, we need more data scientists, yes, but you don't train them overnight. That's my opinion.
That's true.
Do we have time for one more question?
All right.
Richard, thanks for the talk. This is like a sort of like follow-up question to Gary's question, but you were sort of reluctant to draw any, general recommendations for researchers. Do you think there's any room, at least within certain fields or certain subfields, to have is there any idea of having like some common like ground rules for what counts as evidence? Or do you think there's, in terms of like, there could be like a problem in terms of like coordinating and even having, if you have so much flexibility in terms of like how you pick up your assumptions for your model, I guess my question is, do you think that we should take seriously the costs of communicating and evaluating evidence between researchers, at least within a subfield?
Yes, we have to, right? We don't have a choice. There's no, you have no other option but to have some sort of lingua franca and ground rules about what counts as evidence in a field, right? Otherwise, how would you communicate? Now, what those would end up being, I think that is something for the individual fields to decide. And I think what we're having right now, that's the discussion that we're having right now as a response to the replication crisis, right? I mean, we're arguing about Bayes factors and p-values and all of this, and we're developing these ground rules as we speak. And I think that this is all very valuable discussion. I think that science will end up, and statistics will end up being stronger for the fact that we have had these discussions, right? These are the very discussions that we're having. Now, I think that we really have to stop thinking about the ground rules as being invested very strongly in particular computations of test statistics or the like, right? There's so much more going on than that. Transparency in data analysis, like general transparency in data analysis, graphical methods, the release of open data, the transparency of experimental methods and the like are huge issues that we need to have ground rules set about those. And I think that's where most of the conversation should probably be. I think that the questions about Bayes factors and p-values are not nearly as important as, for instance, transparency in experimental methods or data analysis or releasing your data, that kind of thing. But definitely, yes, ground rules are very important.
Thanks.
Great, thank you. Thank you so much for that illuminating talk, Richard. I'm going to end it there. And if people want to ask further questions, we have this procedure where you would ask questions on the Phil Stat Wars blog. right on the day, you know, in other words, the comments for that particular blog days where you put your questions. You'll find on my blogs also the link to sign up for this debate. And I want to say, I really don't know anything about this debate except that Daniel Jeske asked me if I wanted to be in a debate with Jim Berger and David Traffenau way back in July or something. And he wanted it to parallel the presidential debates, which is kind of funny. So I don't know, you know, what that will be like. I'm pretty nervous about it, and I'm really glad to have at least this ammunition on the Bayes factor front. Look out for that link. I mean, it has been on my blog because you'll have to register separately. And I hope that you'll come, even though, well, you could say it's a side issue, as you're just saying, and other people have said, why are they making such a big deal over it? But I think it has to do with the American Statistical Association being all about p-values and whatnot. Okay, thank you.
Thanks everybody for coming.
Thank you.
Thank you. Bye.
Bye-bye.
I like your point, Christian, yeah.
I will write this other question that Richard actually did.
Oh,
In your blog, right?
Huh? Why should we use the prior? Why should we use subjective?
No, the other.
Or if you don't want to be subjective, why have prior?
No,
the
other question. The other question.
What was the other? We're just miscellaneous.
Should I write it in your blog?
Yes.
Okay, good. I'm going to do that.
All right. I will sign out.